Okay, first I will explain the Newton-Raphson method implementation using MATLAB. First I defined the function which it is x to power 3 minus 2 x to power of 2 minus 5, and defined its derivative and of course I wrote some comments so the code will be more clear. Okay, the user here is promoted to input the starting point x0 and the minimum error and the maximum iteration. Of course here is the text will appear, so the user will input the values. After that here initializing the variables x, iter and errors. X is for the current approximation, iter for the iteration count, and errors to store the errors in each iteration. Here while loop, this line starts a while loop that contains iterating as long as the variable iter is less than the maximum number of iteration, which it is max iter. And in this line, inside the loop, this line is increments the iteration count by 1, and it keeps track of how many times we have gone through the loop. Okay, and after that here we store the current approximation x in a variable called x previous. This is done to keep track of the previous approximation for calculating the error in the next step. And here of course is defined for the Newton-Raphson method formula, which it is x previous minus f of x previous, function of x previous, divided to derivative of function of x previous. Okay, and here we calculate the error between the current approximation and the previous approximation. This gives us a magnitude of the difference between x and x previous. Okay, and in this line we append the current error value to the errors array, so the error is stored in the errors array. And here of course it brings out the information about the current iteration. It display the iteration number, the current approximation x, and the error. The format is here, the format specifier ensure that the value are displayed with 3 decimal places. Okay, and in this line finally checks if the error is less than the minimum allowable error, which it is mean error. If the error is below this threshold, the loop breaks and the iteration process stops. So it stops if the error is less than minimum error. Okay, and here of course for defining or for the graph will be appearing, we plotting the function. Here the code generates a range of x values for plotting the function. Here line space is a MATLAB function that helps to create a range of evenly spaced values between 2 points, and in this case I'm using to generate 1000 evenly spaced values between -5 and 5, and here of course it evaluates function fx at these x values to get corresponding y values, which it is y values, and it plots the function curve using plot. And this arrow is a red circle marker to plot the estimated root x, and it adds labels title and grid. Title will be Newton-Raphel method, and a grid, and x label and y label. And here it's all same for the graph of error. And the code creates a new figure to plot the errors. It plots the errors against the iteration number using plot, and it adds labels, title and grid to the plot. And that's it. Now I will run the code to try it. For example, the starting point is -1, and the minimum error is, for example, 1e -5, and the maximum number of iteration is 4. Okay, now this is the graphs. Here it plots the estimated root x on the function curve, and here is the error against iteration graph. That's it, and thank you.